What is heat flux and thermal conductivity? Imagine you're holding a hot cup of coffee. You can feel the heat moving from the cup to your hand. That movement of heat is what we call heat flux. It tells us how much heat energy is passing through a surface each second for every square meter of area. Think of it as the rate at which heat flows through a material. The units used to measure heat flux are watts per square meter. Watts measure power, or how much energy is transferred each second, and dividing by the area gives us the flux. Heat flux isn't just about how much heat is transferred, but also the direction it moves. It's a vector quantity, meaning it has both magnitude and direction. When we talk about heat flux in the context of thermal conductivity, we're describing how heat moves through a material because of a temperature difference across it. If one side of a metal rod is hot and the other side is cooler, heat will flow from the hot side to the cool side. The amount of heat passing through depends on how hot one side is compared to the other, and how well the material conducts heat. This is where Fourier's law of heat conduction comes into play. It states that the heat flux equals the negative of the thermal conductivity times the temperature gradient. The negative sign just shows that heat flows from higher to lower temperatures. So, if the temperature difference gets bigger, or if the material is better at conducting heat, the heat flux will increase. Materials like metals have high thermal conductivity, so they transfer heat quickly and produce high heat flux when there's a temperature difference. Insulating materials, on the other hand, have low thermal conductivity, so they transfer heat slowly, resulting in low heat flux. This principle helps engineers choose the right materials for things like building insulation, electronic cooling, or even cooking utensils. Understanding heat flux helps us see how fast heat moves through different materials. It's a key part of designing systems that control heat flow effectively. Whether it's keeping a building warm or cooling electronic parts, knowing how heat flux works allows us to make smarter choices about materials and design. So, in simple terms, heat flux is the measure of how much heat passes through a surface each second, and it depends on the material's ability to conduct heat and the temperature difference across it.